Welcome to a sim code. Hey friends. Welcome back to the channel. Make sure to hit that like button and subscribe for more. This Python code demonstrates k-fold cross-validation using the iris dataset. K-fold cross-validation is a technique used to evaluate the performance of a machine learning model by dividing the dataset into k-equal-sized subsets, or folds. The model is trained on k1 folds and tested on the remaining fold. This process is repeated k times, with each fold serving as the test set once. The results from each fold are then averaged to provide a more reliable estimate of the model's performance. This approach helps reduce bias and variance, as it ensures the model is tested on different subsets of the data and provides a more generalizable evaluation compared to a single train test split. It's particularly useful when the dataset is small or when you want to ensure that the model's performance is not reliant on one specific partition of the data. Importing necessary libraries. For handling numerical operations and arrays. For performing k-fold cross-validation. A sample dataset to work with. A classifier we will use to test cross-validation. To evaluate the performance of the classifier. For splitting data into training and testing sets. Loading a sample dataset. We are using the iris dataset here, which is a small dataset with 150 samples and 4 features. This dataset is available in scikit-learn. Load the iris dataset. Target labels of the dataset shape equals 150. Split data into training and testing sets using train_test_split. It randomly splits the dataset into a training set and a testing set, commonly 80% to 20% split. Setting up k-fold cross-validation. K-fold cross-validation splits the data into k subsets, or folds. The model is trained on k1 of these folds and tested on the remaining fold. This process is repeated k times, with each fold being used once as a testing set. The number of folds, you can adjust this to any number, for example, 5 or 10. K-fold, n_splits equals k. n_splits equals k means the number of splits, or folds, in the data. Shuffle equals true ensures the data is shuffled before splitting, helps in better generalization. Random_state equals 42 is used to set a seed so the results are reproducible. Setting up the k-fold object. Four. Initialize a classifier. We will use logistic regression here, which is a simple classifier that works well for classification tasks. Max_iter equals 200 is the maximum number of iterations to converge. Perform k-fold cross-validation. We will loop over each fold, train the model, and evaluate it. A list to store accuracy scores for each fold. Start looping over each fold. kf.split x_train returns the indices for training and testing data. Train_index and test_index are the indices of training and testing sets for the current fold. Split the data based on the indices from k-fold. Fit the classifier to the training data, model training. Predict using the trained classifier on the test fold, model testing. Evaluate the accuracy of the model on this fold using accuracy_score. Accuracy_score, y_true, y_pred. Append the result to the list of accuracies. Calculate the average accuracy across all folds. np.mean calculates the average of the list. Print the average accuracy across all folds. Test the final model on the testing data. Now that we have evaluated the k-fold cross-validation, let's train the model on the entire training data. And evaluate it on the test set that was previously held out during the cross-validation process. Train the model on the entire training set. Predict on the test data. Calculate accuracy on the final test set. Print the accuracy on the final test set. Now run our code. I hope you liked the video. Be sure to like, comment, and subscribe.